Okay, guys, welcome back. Chapter 10, Section 2 on banking and investing. This is compound interest. I do not like the way the book explains how to do compound interest. They don't actually use the compound interest formula. They actually use the simple interest formula, and then they have you add on to the next one and then do it again and again and again. And it gets repetitive. It stinks when you got to do it 12 times because it's being compounded 12 times annually. So there is a formula for that. So the compound interest formula is the principal times 1 plus, that's always the same, 1 plus, R over N, where R stands for the rate of interest, N stands for the number of times being compounded, to the NT, where again N is the number of times being compounded. So these two numbers should always match, and to the time. So let's look at the example they give us. Here's the example, and you can see the way they do it is they use the simple interest formula. They get an answer, they add it on, and then they do it again because it's being compounded twice a year. So the example says Kim deposits 100 into an account that earns 4% interest, compounded twice a year. Calculate the amount in the account after 1 year. So that's the way that they do it. I guess it's not that bad because it's only twice a year, but there's examples in here where it's compounded 4 times, 6 times, and 12 times. And you'd have to do this 12 times, which would be way too long. So that's why we're going to use the compound interest formula, which is right here. So let's use it for the example that they give us. So the example says you got $100 to deposit. So according to our formula, the principal would be $100 times 1 plus the rate, which is 4% as a decimal. You are compounding it twice a year, so that's over 2. To the, we know this has to be the same, times, and it's only for 1 year, so times 1. Okay, that's the time in years. So I know 2 times 1 is just 2, so we're going to do 100 1 plus 0.04 over 2 to the second power. So when I get my calculator out, it's going to do the work for me. So it's going to be 100 times 1 plus, now we got to put this fraction, that 0.04 over 2, put that in parentheses. So you're going to open up another bracket, 0.04, divide 2, close it. Now that just closes that fraction. So now we got to close it again to incorporate the whole amount. Okay, and that's to the second power. And your answer is $104.04, which is right here. So let's do exercise A. We'll do a few examples there. Okay. Exercise A says that we're going to compute the new principal at the end of 1 year when the interest rate is compounded semi-annually. Okay, semi-annually means twice per year, and we want to know for 1 year. So our T is 1. Our semi-annually means N equals 2. So now we know what the rate is. We know what the principal is. Is use the formula. So here it'll be 100 times 1 plus the percent or the rate, 0.06, over our N, which is 2, to the NT. Our N again is 2, our T is 1, so we know 2 times 1 is just 2. So when I plug it in the calculator, 100 parenthesis 1 plus 0.06. Oops, remember, got to put this in a parenthesis itself. 0.06 divided by 2. Close it again, and it's squared. Enter. $106.09. Or 9 cents. Okay. So now, what happens when it's compounded quarterly? Quarterly means 4 times. So 4 times per year is going to compound. So that's our N. For 1 year, that's our T. So let's see what happens under, and let's do number 2. $200 for 5.5%. So again, 5.5% is a decimal, and we know a half is 0.5. So what is 5.5% as a decimal? That's going to be 0.055. So let's plug in. It's going to be 200 times 1 plus 0.055 over my N, which is 4. And again, it's for 1 year. 4 times 1. Oops, 1. Okay, 4 times 1 we know is just 4. So when I plug it in, it's going to be 200, parenthesis 1 plus, parenthesis 0.055, divide that by 4 to the 4th power, and we get, oh, I made a mistake because I forgot to do a double parenthesis at the end. So let's do it again. 1 plus parenthesis 0.055 divided by 4, double parenthesis to the 4th. So it's $211, and it's round to the nearest cent, 23 cents. Okay, now let's do it again when it's monthly. So monthly, we know up from our chart here is 12 times per year. So our N equals 12. At the end of 4 months, so 4 months would be 4 divided by 12. So it's not for 1 year. It's going to be for 4 over 12 as a decimal. Is 0.3 run on. So the way we could actually enter it in our calculator is we could put it in as a fraction, or we can just do 0.3s going across. That's fine. We'll do that for now. Okay. So our time is 0.3 run on. So we'll just go like this. So let's do the first one. We get 1,000 times 1 plus the rate, which is 6% in this case, so 0.06 over 12 times 12, or to the 12 times 0.33 run on. Okay, so we put that in our calculator. 1,000 parenthesis 1 plus, open up a parenthesis, 0.06. Divide that by 12. Close it. Close it again. To the 12 times 0.333333. Enter. And we get 1,020.15. Okay, so essentially, for keeping $1,000 in the bank for 4 months, you're getting, at a compounded monthly interest, you're going to get an extra $20.15 into that bank account. All right. Okay, moving on. What happens if you get something that's compounded daily? Well, if it's your savings account, that's great, because you're going to be doing this to the 365th time. But lucky for us, they actually gave us a nice chart between 5% and 6.5% of compounded daily interest over a number of certain years, up to 25 years. So when you go to the exercises here, let's look at the example. It says Christopher wants to know how much his $9,000 investment will be worth in 20 years at 6% interest, compounded daily. So we're going to use the table at 6% interest daily. 6%, go to 20 years. So we're at 3.320. So that's where you get the 3.320 times the 9,000. and you're at 29,880. So that's nice that they gave us that chart, because now we're just multiplying two numbers after we find that decimal. So let's take a look at our example here. We're using compounded daily. All right. So we know we're going to use the chart. It tells us to. So the first one says $2,500 at 5.5% for 10 years. So 5.5%. There's 5.5%. Go down to 10, and we're at 1.733. So for number one, it's going to be 1.733 times 2,500. So I'll go to my calculator. 2,500 times 1.733, and we are at $4,332.50. So compound interest is a wonderful thing. It keeps adding on and adding on and adding on every single day. So it doesn't just go back to the original investment and do 5.5%. The first time it does it, whatever the 5.5% is going to be of 2,500, you get a new answer. Now you're going to do it again onto that new answer. So it's taking interest of interest. That's why compounded interest is a very wonderful thing when you start investing money. And let's go ahead and look at the very last part here. So again, we want to find what the new balance is and what the interest is here on a 2-year loan. Okay. And it is just compounded in 1 year. All right, so it's 1 year here. So here we're going to use our formula again. Let's do number one as an example. We're going to have the principal of 800, and 1 plus the rate is 8% over is only compounded once per year for a total time of 2 years. So this is going to be just 1. So compounded once per year or yearly times 2 years. 1 times 2 we know is 2. So go to our calculator. It's going to be 800 parenthesis 1 plus parenthesis 0.08 divide 1, close it again, to the 1 times 2 we said was 2, hit enter. So we get 933, 933.12. So the total interest on that, you subtract these two numbers, 933.12 minus 800 is $133.12. So that was your total interest. So this is compound interest. This is going to take you a little bit. You got to get used to that formula, how to use it. If you have any questions, just let me know.